Welcome back. Over the course of this course, we have used imports a number of times. In this video, let's quickly revise them. Let's get started. I'll create a simple class as usual, class, and I'll call this imports runner. And let's put this in com in 28 minutes dot tips slash imports. And let's add a main method and finish. What we want to do is we would want to look at something called imports, right? So if I say string str is equal to this, do I need to really import this string class? I'm using the string class in here, but am I importing it in? Do you see an import in here? Nope. Why is it so? The reason it is so is because string is in a package called java.lang. Java.lang is part of the default imports. So even though you don't do a import, it's almost like you're doing a java.lang.star import. So this is kind of what is happening in the background. And when I say this, you'd see that it says java.lang is unused. Or I can say import java.lang.string. So over here we're specifying the import for a specific class. This is the way you would specify the import for everything from a package. However, the important thing is the fact that java.lang is imported in by default. So if you are using anything in java.lang, let's press this. So I've opened up string class by control and clicking this, or if you're on Mac, command and clicking it. And once you have opened it, I'm clicking this thing in here. So once we click this thing in here, this class is shown in the jar file, and you can see that there are a lot of stuff which is present inside the java.lang. So I would recommend you to take a look at what is present in the java.lang. You can use all these classes automatically without specifying an import because they are in the java.lang. Instead of string, let's say I was using big decimal. It doesn't really matter, right? So we are looking at imports. You'd see that I would need to import it in. So it gives a compilation error because it's in java.math package. So import big decimal would actually try and import it in this way. One of the best practices in Java is whenever you do an import, import a specific class. Don't use something like a star, which is used in here, because that's not a good practice. Typically, the good practice is to import all the specific classes. The important things that you need to remember about imports is that by default, java.lang package is imported. You don't really need to specify java.lang. And all the other classes that we want to make use of, we have to do an import for them. An interesting thing would be something called a static import. Let's say system.out.println. So this is something which we keep doing, right? We kind of say system.out.println imports. This is how we typically write code, and when I run it, it would print imports, right? Instead of specifying system dot every time, what we can do is we can do something called a static import. We can do something called import static, the package for system. I'm doing a control click. It's java.lang, right? So you can say import static java.lang.system.out. So what I'm doing is I'm doing a static import of the system.out.method, and now I don't need to specify system.out anymore. So whenever I use system.out.println, I can just do this. So I can say out.println static imports, and we can run this and you'd see that it's printed. So instead of calling system.out.println each time, if we do a static import, then we can directly do something of this kind, out.println imports. Over here, until now, we had done a static import of a variable. So inside the system, there is a static variable called out. So you can see that there is a static variable called out, and we used static import to import that. And from now on, I can say out.println and all that kind of stuff. You can also do static imports with methods. So let's say you are doing collections.sort. So let's say I'm doing a collection.sort, right? So collection.sort, I don't really care about it, so I'll say new array list. Actually, this should be something really which is a real list which you need to use in here, but I'm lazy, right? So I'm creating a new array list in here directly. So first thing I would need to do is I would need to import array list in here. So let's import array list. You can see that there is a new java.util.arraylist coming in, and now I would need to do an import of collections as well. So over here, what we are doing is we are importing ArrayList and collections in to be able to execute this line of code. Sort is a static method on collections. So instead of always calling sort and collections.sort, you can also say import static. I know collections package is directly in here, and you can say import all the static methods inside collections. And now what I can do is I don't need to specify the type. So I don't need to specify collections, and I don't need to specify the import as well. What is happening in here is a static import of all the methods which are present in the collections class. From now on, I can just call it sort. I don't need to say collections.sort and import it in. These are very useful when I'm, let's say, using sort in a specific class 1,000 times. I don't want to be maintaining that class, but yeah, let's say there is a specific method, static method, which you are using multiple times in a specific class. You don't need to use the class name dot the name of the method each time. You can just call it by the name of the method and do a static import in this specific way. In the short step, what we looked at is the default import, which is java.lang. After that, we looked at importing static variables, java.lang.system.out. After that, we looked at importing static methods, java.util.collections.star. I would recommend you to try and take another example of a static method and try and import it statically and try and make use of it. Until the next tip, bye-bye. Welcome back. In this tip, let's look at something called blocks. We have been using if blocks, for blocks a number of times. In this specific tip, we'll look at it in a little bit more detail. Let's create a new class. As usual, new class, I'll call this blocks runner, and I'll change the package tips, not imports, we would want to call it blocks, right? And let's add in a main method and finish. And over here, we looked at if conditions a number of times, right? So if let's say 3 greater than 2, then do something. System.out.print 3 greater than 2. This is what we have done a number of times. So anything between the curly braces is called a block. So this is a method block, this is a code block, this is a if condition block, right? You can also have a else condition block, and so on and so forth as well, right? One of the important things is not using curly braces and writing code like this is a very bad practice. So what would happen is somebody might come and add in code like this, right? And they might be thinking, okay, this is in the if, but actually only the first statement is inside the if, right? So I would need to if you have multiple statements, to put them under if, you need to have a block. The fun fact is that you don't really need a if condition to have a block. This is valid. See, this is cool as well. I can even declare variables in here. So I can say int I. The thing is, once I declare a variable in a block, it's only useful inside that block. I cannot say over here, I cannot go out of the block and say system.out.print I. That's not allowed because I, it says, nope, I cannot be resolved to a variable. So a variable which is declared in a block. So there might be a statement of code which is present in here. Let's type in quickly something in here, system.out.println main. So I can have some statement of code in here and start a block after that. And within the block, I can declare variables and I can also have logic in here. This is kind of a tip. I have never seen code which does something of this kind. But the most important thing for you with blocks is to make sure that you use braces, or you make sure that you have a specific block created whenever you're using a if or a for or a while. Whenever you have conditionals or loops, make sure that you're using blocks. Blocks are considered to be good practice. I'll see you in the next tip. Until then, bye-bye. Welcome back. In this tip on Java programming, let's look at something called a equals method. Let's create a new class. I'll call this equals runner as usual, and equals as the package name as well. Let's have a main and finish. What I would want to do is create a simple class. So over here, what I can do is actually create a class in here. So I'll call this class client. And let's say this guy has an ID. So let's make it private int ID. And let's add in a constructor, generate constructor using fields, and say we have an ID present in here, right? One of the important things that we have learned earlier when we were talking about equals is by default, two objects are equal only if they are referring to the same object. What does that mean? Let's create two clients, right? So client C1 is equal to new client of 1. And I'll create a C2 with the same ID. So both these clients have the same ID. So typically we would kind of think of them as the same client. However, if you go ahead and do something called equals, there's a method called equals. So let's do sys out and say C1 dot equals C2. What do you think this would print? Let's run this. Aha, it says false, even though they have the same IDs, because by default the equals method would only compare if they are the same object. It does not look at the values. It just sees, okay, are they the same object? Nope, C1 is different from C2. If you do C1 equals C1, what would be the output? The output would be true because they are the same object. Or C2 equals C2, you'd get the same output. But if you do C1 equals C2, you'd get a false back. The default implementation for equals method is provided by the object class. As we know, all classes in Java which does not extend anything inherit from object class. So we are inheriting the default implementation from the object class, which only compares if they are the same object, if they are present in the same memory in location. That's basically what it compares. But we would want to add logic to this to say, okay, I would want to do a little more than that. I would want to compare the IDs of the objects. That's where equals and the hashcode methods come into picture. You can say, I've said equals method. Why do we need to talk about hashcode also? Don't worry about it. We'll talk about it a little later. For now, what we'll do is over here, I'm inside the client class. What I'll do is I'll do right click, source, and say generate hashcode and equals. That's the awesome thing, right? We are using Eclipse. So instead of writing the code for hashcode and equals, I'm getting Eclipse to generate it for us. Generate hashcode and equals. I would want to use the ID to compare. And let's go ahead and create this. Now, you'd see this is the default implementation which is generated for hashcode and equals. Like instead of obj, I actually like calling this that. So I'll say instead of obj that, so you can say right click, refactor, rename, and say that. So if this is equal to, so that is the object that we are comparing against. This is the current object. So if this and that are the same object, return true. If that is equal to null, if that is null, that means they are not equal because there is an object with this and that is null, so it's false. And if the classes, so we are comparing the classes, if the classes are not the same, if that belongs to some other class, then return false. You can see that the parameter which equals accept is of the type object. It is not of the type client, it is of the type object. That's another thing that you need to remember. Over here what we are doing is we are getting the client, other client, and comparing the IDs. We are saying if IDs don't match, then return false, return true otherwise. So if the IDs of two objects are the same, then we would return true back. If this logic is a little bit confusing, don't worry. Try and do a debug and you should be able to easily understand what's happening in there. For now, what we'll do is we'll run this program. So we have generated the equals method and now you can see that this is printing true. This is actually comparing 1 and 2. Now if To make sure that it's working, I'll create a C3 and I'll have a client with an ID 2 and C1 dot equals C3. Let's run this. This returns false. That's cool, right? So C1 and C3 have different IDs. However, C1 and C2 have the same IDs. So we were able to return true back. So in summary, what we have done in this specific step is we discussed a little bit about the equals method inside the object. By default, the equals method in the object only compares if they are the same object. So the logic would be something of this kind. If this is equal to that, return true. Otherwise, return false. This is the default implementation which is present in object. So all this code will not be there. We generated an implementation which compares the IDs using Eclipse. What we are doing in here is if the IDs are the same, then we return true back. If the IDs don't match, then we return false back. There's one thing you might not understand. Why did we generate the hashcode method? We'll look at it in the next tip. I'll see you in the next video. Until then, bye-bye. Welcome back. In the previous step, when we implemented the equals method, we also implemented the hashcode method. The way Eclipse generates it is right-click, source, generate hashcode and equals. There is nothing called generate equals or generate hashcode separately. It's combined generate hashcode and equals. Why is it so? And what is the importance of hashcode? That's what we would be discussing in this specific tip. Let's take a step back and look at how hash map works, right? When we create a hash map, internally we use something called buckets. How is an object allocated to a bucket? We said it is based on a hashing function. This hashing function is nothing but your hash code. So based on the hash code value, objects will be placed into different buckets. The efficiency of a hash map depends on the hash code implementation. So whenever we are creating a hash map and adding a specific class, you need to make sure that the hash code implementation is good. You need to make sure that the hash code implementation properly distributes values into different buckets so that in a specific bucket, you don't want 1000 objects and 0 objects in the other ones. You would want equal distribution of objects among all the buckets. That's what the default implementation of hashcode provides in here. There are a few things that your hashcode function should satisfy. One of the things is if two objects are equal, so if the IDs are the same, then their hash codes also should be same. The second thing is the value of the hash code should not vary unless the ID changes. So the value of the hash code should not be x at one time and y at another time. And for these two reasons, we would recommend that whenever you implement the equals method, you also implement the hashcode method compliant with these two properties. The exact implementation of the hashcode method is beyond what you would need to understand as a beginner. The important takeaways from this specific video are: 1. Whenever you implement an equals method, you should also implement a hashcode method. Your hashcode method should distribute the objects evenly among the different buckets. That's the most important thing about a hashcode method. And the two properties which a hashcode method should always satisfy are: if two objects are equal, then their hash codes should also be equal. And also, hash code should not change unless the values of the object changes. Those are some of the important takeaways about equals and hash code. As a beginner, I can understand that some of this code that you are looking at in here is confusing, but as you gain more experience, you would see that these become much more easier to understand. Until the next tip, bye-bye. Welcome back. In this tip, let's look at something called access modifiers. There are multiple access modifiers: private, public, default, and protected. What are all these and how are they applicable to classes, variables, and methods? That's what we would want to learn in this tip and the subsequent tips. In this tip, let's focus on the class level access modifiers. Let's get started. I'll create a new class. I'll say class access modifiers, and I would use the package com in 28 minutes tips. I'll say access, and I'll call this package 1. So in access, we are creating a package called package 1, or you can call it package A. Package 1 is fine, I think, and let's go ahead and create a main method as well. Typically, the access modifiers which are allowed are public, protected, default. I'll put it in parenthesis as it's actually absence of an access modifier. That's what makes it default, and private. All these access modifiers are used to enforce encapsulation. These don't really protect you from outside security threats. These actually help you to decide what kind of things in your class are accessible to people who write code outside your class. If I say something is public, so public class access modifiers, this means that this class can be used from anywhere. So not only this package, so I can, in this package, I can say class access modifier C is equal to new. So in this class itself, I'm able to create an instance of the class access modifiers. You'd see that even if I had a different package, let's create a new package. I'll copy this, Control C, Control V, Control C, Control V, and I'll call this package 2. So access.package2. And what I'll do is I have the class access modifiers class also created because I copied this in. What I'll do is I'll rename this. I'll not want to have this as class access modifiers. Let's call this class access modifier runner in other package. I'm just calling it class access modifier runner in other package. Right click, refactor, rename. Continue. Cool. I would want to delete this line of code in here, right? So now what is happening in here is this is in another package. Class access modifiers is in a different package. If this class is public, then what would happen is I can use class access modifiers class in other package as well. So even in here, I can use the class which is in a different package. So even though this class is in package 2 and this is in package 1, I can use that specific class. Now what I'll do now is I'll go and remove the public. I'm removing the public from here, and you'd see that there's a compilation error. Why is there a compilation error? Let's see the import. The type is not visible because a default access modifier class is only visible in the package in which it is created. So inside the same package, it's visible. Inside the same class, it's visible. But outside that particular package, in a different package, package 2, it's not really visible. That's your tip number 1, right? So a public class is visible everywhere. So once I say a class is public, it's visible everywhere. But if I remove the public, then this becomes default class, and the default class is only accessible inside the same package. So you can use it in this package or sub packages of this specific package, but in all other places, it's not available. That's tip number 1 for this specific video. Tip number 2 is that you cannot use protected on a class. So on a class, you cannot say either it's protected or you cannot even say it's private. Public and default, that's basically the absence of the keyword public, are the only 2 modifiers that you can use on a class. I'll see you with more tips in the subsequent videos. Until then, bye-bye. Welcome back. In the previous tip, we talked about class access modifiers. We learned that the only access modifiers that can be used on classes are public and default. And default classes cannot be used outside that specific package. And we also learned that protected and private cannot be used on classes. Now, what we'll do now is we would look at something called method access modifiers. So what are the access modifiers that can be present on a method? To understand the different access modifiers, what we'll do is we'll create a new runner class. So I'll say Control N, and I'll create a new class, method access runner, and I'll say create a main method. Let's use package 1 as well in here. So we have a method access runner in here, right? So method access runner is present. What we'll do also is create a simple class. So I'm going to the package 1. In the package 1, I'm creating a class. What do I want this class to do? Let's look at it right now. Right? So let's call this example class. And over here, let's create different kinds of methods, right? So I'll create a public method, public void public method. Let's not really do anything in here. What we want to check is if this can be accessed or not. Protected method. So how can I say something is a protected method? How do I need to say? Yep, it should be protected in here, right? Now let's create a private method, right? And the last one I would want to create is a default method, right? So these are all the things that we are actually creating. I need to rename this. It should be default method, right? Let's create a main method also in here, main. And over here, let's create an instance of the example class. Example class is equal to new example class. And over here, let's try and do example class dot. And you can see that I can use private method, protected method. I can call public method, and also I can call default methods. That's cool, right? So inside the same class, so this is main method which is present inside the same class. Inside the same class, I can access everything. That's not a problem at all. That's cool, right? Now, this is a method access runner. So what I'll do is I'll copy the same code in the method access run into method access runner. I'll rename this. Actually, I'll have to call method access runner. This is inside same package, right? This is inside same package. So method access runner inside same package. So right click refactor rename should be easy. So the thing you'd see is only the private method does not compile. So inside the same package, you can access all the things except for private. So you can access protected, public, and default, but you cannot access private. Let's now copy this method access runner inside same package to package 2. I'm copying this Control C and doing a Control V. And you can see giving a compilation error. Let's rename it first. I'll say method access runner in different package and say continue. Let's import the example class. It's imported in. Now you can see that even protected and default would give you compilation errors. This is because in a different package, you can only access the public methods in the class. You cannot access private, you cannot access protected, and you cannot access default as well. All these are not accessible. Until now, in this specific video, we saw examples of what would happen when I have a private method, protected method, public method, and default method, and access it from the same class, same package, and a different package. Let's look at it from the perspective of an example class. If you declare any method as public, it is available everywhere. So wherever you can access the example class, you can access the public method. Whether it's the same package, different package, anywhere you'll be able to access it. Protected, on the other hand, can only be used either in the same package or in subclasses. So if another class extends example class, then you'll be able to use the protected method in there. Private methods are only available inside that specific class, nowhere else. Default methods are available only inside that class and the same package. If you go outside that package, even if you inherit, you will not have the default methods available. A good understanding of all these is important because when you create your classes, you need to decide what kind of things you would want other classes to access. So you'd always need to think about, okay, what are the things my subclasses need to be able to access? You need to make them protected. What are the things every class needs to access? Okay, those things I would make them as public. All the other things you should make them private. This would ensure that your class is properly encapsulated. One of the important things is whatever discussion that we had about methods is equally applicable to variables. However, you don't really want to make any of your variables public unless those are final variables which are not going to change in value. All the other variables should remain private most of the time. You should allow access to these private variables through methods of various access levels, protected or public. Until the next tip, bye-bye. Welcome back. In this video, let's look at the final non-access modifier. In the previous tips, we looked at access modifiers, public, private, protected, and default. There are also things called non-access modifiers. These are final and static. In this video, let's look at final access modifier on methods and classes. What would happen when I put a final on a class or a method? Let's create a new class. I'll call this final. Actually, it's non-access, so final non-access modifier, and let's say runner. Final non-access modifier runner, and over here I would want to have a main method as well. So let's go ahead and run this. Now let's create a couple of classes, right? So I'll say final class, final class. Cool. Now what happens when I put final before a class? What would happen? What do you think will happen? Let's try extending this class. So class, some class extends final class. Compilation error. It says type some class cannot subclass the final class, final class. The important thing is when you call a class final, that means it cannot be extended further. Nobody can inherit from that specific class. That's final. Why do you want to make a class final? Good question. Let's look at string class. So I'm opening up the string class, Control-Shift-T, Command-Shift-T, or opening up the string. You can see that string is a final. So in Java, string is a final class. You can look at the wrapper class integer. It is also a final class. That means nobody would be able to extend string, integer, long, or any of that kind of wrapper classes. Now, why is it important that you make a class final? Whenever you think you don't want to allow extension of your specific class, you don't want somebody to extend the functionality in your class and modify the behavior of your class. One of the important things to realize is that whenever somebody extends your class, they have the privilege of modifying some of the code of your methods. And that might not be something you'd want to allow in certain situations. If you look at string class, it is used as hash code. It is used to decide where an object is stored in memory and all that kind of stuff. So it's kind of a sensitive class, and Java decided that nope, I will not allow extension of a string class, and that's why it's labeled as final. And the thing is, not just classes, but methods can also be declared as final. So let's comment this just to keep the code compiling. Let's create a new class, right? Class, some class, and let's have a method which is present in here. Let's say this is a public method. It returns void, and let's call this do something. Let's not really worry about the names of the methods. What we are really interested in is what is happening when I put final on the class, right? So I'll say class extending class extends some class, right? Typically what I can do, I can override the definition. So this is fine. But what would happen when I put a final inside the method? So I'm making this method final. You can see that there is a compilation error coming up. It says cannot override the final method from some class. It says, nope, this method do something is final. That means you cannot change the code of it. You cannot override it at all. So a final method cannot be overridden. A final class cannot be extended. That's the way you can remember it. Why do you want to make a method final? If you remember, we created something called a recipe, right? So we created a class called abstract recipe where we decided these are the steps that are present, and all the other subclasses can get to implement all the steps, but they cannot change the logic. In those kind of situations, so if you want none of the subclasses to change the execute method, you would want all the subclasses to strictly follow this order. This should be 1, this should be 2, this should be 3. Then you can actually put a final. Once you do this, then none of the subclasses would be able to change the order of execute. It will always be get ready, do the dish, and clean up. Okay, there you go. That's some of the important things related to final access modifier. A final class cannot be extended, a final method cannot be overridden. And I'll see you in the next tip. Until then, bye-bye. Welcome back. In the previous video, we looked at final class and final methods. In this step, we look at final variables and final arguments. Let's get started with the final variable. So let's say I have an int I has a value of 5, and let's say at a later point in time I am saying I is equal to 7. This is allowed because variable's value can change, right? But let's say if I want a variable's value not to change at all, that's when I can put final. So as soon as I make a variable final, you'd see that there's a compilation error here. It says the final variable cannot be assigned. So once you put something as final, it can only be assigned value once. So I can say I is equal to 5. Instead of this, I can say I is equal to 5 as well. This is also allowed. First time you can assign a value, but you cannot change it. You can assign a value once, but not more than once. So final variable, the value of it can only be assigned once, and after that it cannot be changed at all. Now, what's a final argument? Right, so let's look at it. Let's copy this class, cut. Let's take this method, public void do something. I'll say do something else, and let's have a final int argument, final int arg. Right, so if it's a normal argument, no final in here, then I can say arg is equal to, I can change the value of argument, right? It's not a good practice. I mean, the most important thing to realize is changing the value of an argument is not really a good practice, but it's allowed. But if I make it final, what would happen? Aha, compilation error. This is not really allowed because this is final. Once an argument is final, you cannot change the value of it. Now, you might be asking, when should I use final? When should I use final on variables? When should I use final on arguments? The answer is typically final is recommended on all variables and all arguments. Typically, you should assign values to variables only once, and you should assign values to arguments only once. You should not keep modifying the values of variables. This is called immutable programming, and that's recommended because it leads to code which is easily understandable. That's why you'd see coding standards. A lot of coding standards recommend, okay, every variable should be final, and if you don't use final on a variable, it would come up as a coding standard violation. While it is not possible to have every variable as final, at least attempt to have most of the variables as final, where you would only assign values to them once. In this quick tip, we looked at final arguments and final variables. A final variable can only be assigned a value once. And the same is the case with a final argument. You cannot change the value of a final argument inside the method. I'll see you in the next tip. Until then, bye bye. Welcome back. In the previous step, we understood a little bit about the static variables. We discussed why we need static variables, because we need to share the same data between multiple instances of the same class. We don't want one instance per object. We want a shared instance between all the objects, and that's when we go for a static variable. Now, let's discuss why we need static methods, right? Let's look at that in this specific tip. Let's get started. So, earlier we said player1.getCount. Think about it. Is count belonging to player1 or does it belong to player class, right? So, will player1 have a different count from player2? Not really, right? So, player1 and player2 would have the same count because it's the shared instance between all the instances of player. They'll have the same value for the count. Then why should I access it using player1.getCount and player2.getCount? Why can't I access it through the player itself? So instead of player1.getCount, can I say player.getCount? Player.getCount, right? So that's what static methods enable us to do. So I can say static in here, static public int getCount. This method in here is only accessing a static variable. So you can call it static, and now you'd see that the thing compiles. And let's run this. It's 1, 2. So the value of player count at this point is 1. At the end of this is 2. The thing is, static methods can also be called using instances. So I can still call player1.getCount and player2.getCount, but that's not really recommended. So it's not recommended that you use an instance to call a static method. That's why you get a pointer from Eclipse saying the static method should be accessed in a static way. Why are you accessing it in a instance way? Why are you using an instance? Why don't you call player? The fact that we are using a class name to call the method tells that it is a static method. It's something which is shared between all instances of that specific class. So even though I have multiple instances of this class, there will be only one instance of the count, and this getCount method is shared between all of them. Cool, right? In this method, we tried to understand why we need static methods. We understood that we can call static methods using the name of the class directly. The thing is, we had been calling a number of static methods until now, right? So we used collections.sort. We also used a number of methods to create collections, right? List.off, map.off, and a lot of static methods. This is the first time we actually created a static method of our own. Until the next tip, bye-bye. Welcome back. In this video, let's look at an important non-access modifier, static. When we created the final non-access modifier, what we did was we created it in the package tips.access.package1. I don't really like it, so let's refactor it. So let's call this non-access, control 1, move, control or command 1, and move. So now we would have it in a non-access package 1. That's cool. We'll use the same package for our static modifier example. So let's go ahead and create a new class, static modifier runner, and I'll have a main method and finish, and we have the class ready. So let's go ahead. Let's first look at why we would need static variables and static modifiers. Let's consider a simple class, right? So class, let's call this class player, and let's say I have a string name. Let's make it private as usual. Each player has a name. Let's create a constructor using the name. This is cool, right? So we talked about objects a number of times. So when we say player1 is equal to new player of, you can give him a name, right? So Ronaldo, or you can say new player of Federer, player2, right? So each player would have a separate value for the name. Each player object has a different name. When I change the player name for player1, it will not impact the value for player2. But sometimes you'd want to store values in common. So let's say I would want to store number of players which are created until now. How many players are created until now? How can I do that? If I put let's say over here I can say private int count. What would happen? And let's say each time a player is created, I would do a count plus plus. And let's also create a simple getter and setters. I'll just create a setter, right click source generate. So I'll create a setter or getter for count, right? So what would happen if I print the count of players after this? System dot out dot print ln. Will it store to player1 dot get count, player2 dot get count? What would it print? Both of them are printing 1 because each one of them have their own values. By default, you know that the initial value which would be assigned in here is 0. So once 0 is assigned in here, what would happen is the 0 would be incremented by player 1 and a separate instance of the count variable would be present for player 2. But over here what we are storing is number of players, and we don't want that variable to have a separate instance for each instance of the class. What we want to do is have only one instance of it. How can I make it one instance? That's where static comes into picture. So once I put static int count is equal to 0 and run this program, you'd see that both the player instances are printing 2 because we printed the player 1 got get count after player 2 is created. If I printed it before, it would also print 1 and 2. So the first player is created, the value is 1. The second player is created, the value is 2. So the count variable is shared between multiple instances of the player objects. It's not going to be one instance per object. It's only going to be a common shared one across all instances of the player class. In these kind of situations, we would go for using a static variable. In this tip, we looked at when we go for using a static variable. I would recommend you to try and run this program in the debug mode and look at it and try and understand what's happening with and without the static variable. I'll see you in the next tip where we would discuss a little bit more about static variables and also look at static methods. Until then, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.